Article 315.17 ATWO provides an exception to the standard ampacity adjustment rules for conductors. This exception allows for the use of a higher ampacity for the entire conductor run, even if only a portion of that run is subject to ampacity adjustments. The key condition for this exception to apply is that the section of the conductor run that requires the ampacity adjustment must not exceed 10 feet or 10% of the total run length, whichever is smaller. To clarify, this means that if you have a conductor run where a small portion passes through an area with a higher ambient temperature or is subject to other conditions that would normally require a reduction in ampacity, you may not need to apply that ampacity reduction to the entire run. Instead, you can use the higher ampacity rating that applies to the majority of the run, provided the affected section meets the length requirement. This exception can apply regardless of where the affected section is located along the run. It is not limited to only the ends of the run, but can also be applied to sections in the middle of the run. For instance, if a conduit run passes over an oven or through a hot room for a short distance, this exception could be applicable. The exception also addresses the practice of bundling conductors. Bundling conductors together can reduce their ampacity due to the increased heat generated within the bundle. However, Article 315.17 ATWO allows conductors to be bundled or tied together for neatness and workmanship without necessarily requiring an ampacity reduction, but only if the bundled portion of the run falls within the 10-foot or 10% length limitation. In practical applications, this exception is often used in situations where conductors pass through short sections of high-temperature environments such as above ovens, in furnace rooms, or near other heat-generating equipment. It also provides flexibility in panel installations where conductors are often bundled or grouped together for organizational purposes. It is important to note that the 10-foot or 10% rule must be strictly adhered to. If the section of the conductor run that requires ampacity adjustment exceeds either of these limits, the exception cannot be used and the full ampacity adjustment must be applied. Here are some additional considerations to keep in mind. Firstly, determine the total length of the conductor run. This is the entire length of the conductor from its source to its termination point. Secondly, identify the section of the conductor run that is subject to the ampacity adjustment. This could be due to higher ambient temperature, bundling, or other factors that reduce the conductor's ampacity. Thirdly, measure the length of the section that requires the ampacity adjustment. This is the physical length of the conductor that is exposed to the conditions requiring the adjustment. Fourthly, calculate 10% of the total conductor run length. Compare this value to the actual length of the section requiring ampacity adjustment. If the actual length is less than or equal to both 10 feet and 10% of the total run length, the exception can be applied. Fifthly, if the exception applies, you can use the higher ampacity rating of the conductor for the entire run without applying the ampacity adjustment. Sixthly, ensure that all other applicable requirements of the National Electrical Code, or NEC, are met, such as conductor sizing, overcurrent protection, and equipment ratings. Let's consider a specific example to illustrate how this exception works. Suppose you have a conductor run that is 50 feet long. A 5-foot section of this run passes through a hot area, requiring an ampacity adjustment. In this case, 10% of the total run length is 5 feet, which is equal to the length of the section requiring adjustment. Since the length of the affected section does not exceed 10 feet or 10% of the total run length, the exception can be applied. This means that you can use the higher ampacity rating of the conductor for the entire 50-foot run without applying any ampacity adjustment for the 5-foot section in the hot area. However, if the section passing through the hot area were 15 feet long, the exception could not be used, as this exceeds both the 10-foot limit and the 10% limit, which in this case is 5 feet. In that scenario, you would need to apply the appropriate ampacity adjustment to the entire conductor run or use a conductor with a higher ampacity rating to compensate for the adjustment. Another important aspect to consider is the type of ampacity adjustment that is required. The exception in Article 315.17 ATWO applies to adjustments for ambient temperature and bundling. However, it does not apply to other types of ampacity adjustments, such as those required for voltage drop or for conductors installed in raceways exposed to direct sunlight on or above rooftops. Therefore, it is essential to carefully evaluate the specific conditions that are present in each installation to determine whether the exception can be used. Here's another scenario. Imagine you are installing conductors in a panel. You want to bundle some of the conductors together to keep the wiring neat and organized. The total length of the conductors in the panel is 8 feet, and the length of the bundled section is 2 feet. In this case, 10% of the total run length is 0.8 feet, which is less than the length of the bundled section. However, since the bundled section is only 2 feet long, it does not exceed the 10-foot limit. Therefore, the exception can be applied, and you do not need to apply an ampacity adjustment for the bundling. It is crucial to remember that the exception in Article 315.17 at WO is not a substitute for proper conductor sizing and overcurrent protection. Conductors must always be sized to carry the intended load, and overcurrent protection must be provided to protect the conductors from overload and short-circuit conditions. The exception simply allows for some flexibility in applying ampacity adjustments in specific situations, provided that the length limitations are met. Failure to properly size conductors and provide adequate overcurrent protection can result in overheating, damage to equipment, and even fire hazards. Therefore, it is essential to consult the NEC and other applicable codes and standards to ensure that all electrical installations are safe and compliant. In addition to the length limitations, it is also important to consider the specific requirements for conductor ampacity that are outlined in Article 310 of the NEC. This article provides detailed tables and guidelines for determining the ampacity of conductors based on their size, insulation type, and installation conditions. When applying the exception in Article 315.17 at WO, it is essential to ensure that the conductors still meet the minimum ampacity requirements specified in Article 310. For example, if the conductors are installed in a high-temperature environment, it may be necessary to use conductors with a high temperature rating to ensure that they can safely carry the intended load. Similarly, if the conductors are bundled together, it may be necessary to increase the size of the conductors to compensate for the reduced ampacity due to bundling. In summary, the exception in Article 315.17 at WO provides some flexibility in applying ampacity adjustments for conductors, but it is essential to understand the limitations and requirements of this exception. The length of the section requiring ampacity adjustment must not exceed 10 feet or 10% of the total run length, and the conductors must still meet the minimum ampacity requirements specified in Article 310 of the NEC. By carefully considering these factors, you can ensure that electrical installations are safe, compliant, and reliable. Remember that electrical codes and standards are subject to change, so it is important to stay up to date with the latest revisions and interpretations. Consult with a qualified electrical inspector or engineer if you have any questions or concerns about the application of the NEC or other electrical codes.